This video, Cosine Application Part B, completes the second half of the cosine application problem that I started in the video called Cosine Application Part A on my YouTube channel. Now, I will give a brief recap of where we left off. Here's the problem. There's a water wheel that is 12 feet in diameter, and the bottom 2 feet of it are underwater. One revolution of this wheel takes 9 seconds. You notice that there is a leaf on the water wheel, and you time with your stopwatch that it takes 3 seconds for it to reach the top of the wheel. Write a cosine equation for this function, expressing the height of the leaf from the water in terms of time. So, in the previous video, we created this graph to model this situation. Now, we can use this graph to make the cosine equation that this problem wants us to find. To form this graph into an equation, we need to find these pieces of information. First, let's find the period. The period is the distance it takes to complete one full cycle of the function. If we were to graph more than one period, we would see the graph repeat itself. So, if I look at one cycle of this function, I see that the period is from 3 to 12. So if we subtract 12 minus 3, we find that the period is equal to 9. Now that we have found the period, we can find k. 2 pi over k is equal to the period. So if we plug the period in, we have 2 pi over k is equal to 9, and then we solve for k. So, we have solved for k, and we find that is equal to 2 pi over 9. Now, let's find the phase shift. The phase shift is the horizontal shift from the parent function. Our function has moved right 3 horizontally, so for the phase shift, I'll write right 3. Now, let's find the amplitude of our function. The amplitude is the height from the midline, and the midline is just the middle line of the function. So, this is our midline. So the amplitude is the height from the midline of the function to the maximum point. You can also think of the amplitude as the distance from the minimum to the midline, if you prefer. But sticking with the midline to the maximum, the amplitude of our function is 10 minus 4, which equals 6. And now, let's find the vertical shift. The vertical shift is the vertical shift of the midline of our function from the parent function. Our function has moved the midline up 4 vertically. So, our vertical shift is up 4. Now that we have all of these pieces, we can write our cosine equation. The format of our cosine equation is this. Where B is k, D is the phase shift, A is the amplitude, and C is the vertical shift. So now we can just plug the numbers into the equation. So our equation will be this. And you can go ahead and multiply it out and simplify it if you'd like. So in this step I multiplied, and now I can simplify that a little bit. Changing this to the 6 over 9 to 2 over 3. And now we are done, because we have found a cosine equation that models this situation, expressing the height of the leaf from the water in terms of time. If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.